In this short presentation, we will discuss an operator called as Laplacian. Laplacian is an operator just like a differential or a partial differential, which accepts a function as an input and gives a function as an output. So the definition of an operator is that it accepts a function as an input and gives out a function as an output. Laplacian operator is commonly denoted by the symbol inverted delta square. Laplacian actually tells us the direction at which the function increases most rapidly. So imagine we have got a scalar function f of x, y, z drawn in this figure. We can see peak or hill on one side of this graph and a valley on the other side. We can draw gradient of this scalar field. The gradient of a scalar field is a vector field that points in the direction of the maximum rate of change of scalar field at a given point. So these arrows are giving us the gradient of scalar field. The arrows under the peak are all facing each other. This tells us that the rate of change of this function is maximum at the point of convergence of these arrows. Similarly, under valley, the arrows are pointing away, which tells us that in order to increase our descent, we have to go a bit uphill. The Laplacian is defined as the divergence of a gradient of a scalar field. Thus, after drawing gradient of this function, we can find out the divergence. Please note that divergence of a vector field is a scalar function that represents the rate at which the vectors within the field are spreading or diverging from or converging towards a point. In the case where all the arrows are pointing in one direction, we have negative divergence, whereas the case where all the arrows are pointing away from a point, we have positive divergence. Negative divergence can also be called as convergence. Similarly, in other areas, we would have divergence value between these two extremes. So if our f is scalar, gradient of f will become vector, and that vector will be dot product with the divergence, and the final value will be scalar. Thus, we can say that Laplacian tells us how much of a minimum point is x, y, z, or it tells us where minima is. This is analogous to a single variable function where we have double derivative of a function less than 0 at peak and double derivative of a function greater than 0 at valley. And that is comparable with our case where the divergence is negative under the peak and divergence is positive under the valley. Thus, Laplacian tells us how much is the maximum dimension of a minima.